Okay, Assalamualaikum. Okay, so now we go to the div and IDIV instructions. Okay, one of another arithmetic instruction in assembly language. So the div and IDIV instructions is used for division uh, operations. Okay, for unsigned and signed numbers. Okay, for div instruction. Okay, normally we use for the divisions for unsigned numbers or unsigned integers. And for the IDIV instruction is normally we use for the divisions for the sign of two's complement integers. Okay, when we have to do the two's complement integers. So the single operand is being supplied. Okay, is either with using a source operand, either in the register or memory addressing mode, or register or memory operand. Okay, normally which is used is to become the divisor. So the syntax for div and IDIV instruction is using a one operand, which is the opcode is div and the opcode is IDIV. And the source operand, okay, and followed by the source operand. So the source operand can be either a register or memory operand. Okay, or okay. So the div normally used for the signed number, unsigned numbers, and IDIV instruction is used for the signed numbers. Okay. So the source it depends on the size of your register, whether using 8-bit or 16 bits. Okay. So in the div and IDIV instructions, okay, so if your device is 8-bit long, okay, so therefore your AX will be your dividends, okay, the values that will be divided, okay, will be using in the AX, and then the answer or the results, okay, will be put into the AL, and then the remainder will be put into the AH. If your device is 16 bits, okay, so your values or your dividend will retrieve from the DX and AX register as a dividend, and for the answer and the results, okay, the quotients will be stored in the AX and the DX will be stored the remainder. Okay, so therefore bila kita bahagi dalam div and IDIV instruction, kita kena tahu yang mana is divisor, yang mana is dividend, yang mana is a quotient, and where is your remainder. So okay, so when you have a 8-bit divisions, the 83 H divide, okay, by the divide by 2. Okay, so normally, okay, so you will get the answers. Okay, so normally kita dah dapatkan reminder dengan ni, quotient ni dengan mudah kita bagi secara manual instead of you pakai calculator. So you move AX, okay, so 0083H, okay, so in this is an example of div divisions, okay, or instructions, okay, using 8-bit. Okay, so 0083H, you move to the AX, okay, so as a dividend, and then you move the divisor. So normally your divisor will be at your source operand. Okay, where divisor will be at the source operand, so your divisor is 2. So this 2 will be moved to the BL. Okay, so and since you pakai 8-bit, so your div instruction, okay, the opcode, your source operand, okay, of your divisor will be put at the div instruction. Kalau divisor mesti letak dekat dalam source operand. Okay, either register ataupun memory is tak ada masalah. Okay, as long as your punya divisor value must be put into the division punya opcode. Itu yang kamu perlu tahu. And then, bila kita dibahagi during the tracing, the quotients with your answer will be put into the AL at the low byte, and your remainder will be at your high byte. Okay, why? Because bila kita bahagi normally, okay, bila kita bahagi biasa kita bahagi, bila kita bahagi normally the numbers, okay, will become reduced, can become smaller and smaller. Okay, so that's why you kena normally it's advisable for you to do the division manually instead of you pakai calculator. Okay, right. So this is example of the 16-bit divisions. Okay, using a 16-bit mode. Okay, so the values which is a dividend will be put into the AX, and the divisor will be put into a register and put as at the source operand at the top of the opcode of your instruction. Okay, so this A003H will be assigned to the AX, we move into AX, and the CX will be stored as a divisor, and you div CX. Okay, because we use a CX divisor is in the CX, so we div CX. So bila kita trace, okay, when you do some tracing, so the values, okay, the quotients, okay, will be into the AX. Biasanya kita akan letak low to high lah, okay. And then for the remainder, we put into the DX. I will start with the DL first, okay. So this one, okay, kita bagi 8003H divided by 100H in the hexadecimal. So we bagi 80 divided by 100, so 8000. So the 3 will become remainder and the quotient will be stored into AX. Okay, so this is for the signed numbers. Okay, for the unsigned numbers, it can be either IDIV source operand as a register and the IDIV operand for the memory. Same goes, same things. The difference is your IDIV instruction is normally for the sign division. If your divisor is negative or your dividend is negative, automatically you will use the IDIV instruction during writing the code. Example here, okay, you have negative 5 divided by 3. So negative 5 will be your dividend, okay, and your 3 will be your divisor. Okay, so automatically here, this value will be put at your opcode of your instruction of IDIV. So of course, this one, jangan keliru lagi dah. Nak pakai div ke IDIV. So bila ada negative, confirm dia pakai sign numbers. Okay, so bila sign numbers, you kena pakai IDIV, okay, instead of div. So since you pakai 8-bit, okay, so negative 5 divided by, okay, you go to the AL values, okay, and then the 3 will be into the BL or BH is also can, and the better put into the low byte lah, okay, alright, and then the IDIV the BL, not AL. Kalau you AL maksud negative 5 times with the negative 5, dia darab dengan diri dia, so salah lah. So dia, sorry, the negative 5 divided by negative 5, so it's wrong. So kita nak negative 5 divided by 3. So the source will be at your IDIV opcode. Okay. So divisor kena letak dekat opcode. So IDIV with the divisor. Okay. So when you trace negative 5, okay, divide by 3. So negative 5 you divide by 3 with negative 1 times 3 you get negative 5. Okay, minus which is positive 3. So you got negative 2. So negative 1 will be kept into the AL and the remainder will be put into the AH. So they have to complement lah these two numbers. So negative 1 is FFH in the AL and then as a quotient, and then your remainder negative 2 will be represented as a FE and will be stored into the AH. So your AX value will be have a FE FFH. Okay. Alright. So now we go to the examples, okay, inside the questions here. Okay, so this is an example of tracing the questions. Okay, kalau you bagi the portions for partials of the codes, okay, so then they ask you for the AX, BX, and DX, they ask you to trace, okay, which is the result of each of the instructions, okay, partials of it, and then you have to give the end of the result for the particular values or register that will be requested. Okay, so for example here you trace each lines of the code, so move dx which is 0, so your dx will have a 000h, and then move ax. Yang ini tak ada dapat markah, cumanya dia kamu boleh write down into the tracing paper ataupun in your draft paper lah. Okay, and then the 64H will divide put into the AX, and the 0DH will be put into the BX. Okay, so therefore, so your BX have a 00, sorry, dia terlebih 0 kat sini. Okay, so okay, so you have okay. So biasanya kalau macam ni very small portion of the values kita kena tukar dia pada decimal lah, senang. Okay, kita sebab kita boleh bagi dia manual. Okay, so 100 kita bagi dengan 13. So kita akan dapat 7. So 7 kali dengan 13 ialah 91 which is the nearest. So 100 tolak 91 adalah 9. So jadi 7 ni kita akan letak dalam AX as a quotient, and then the 9 will be put into the DX as a remainder sebab we use a 16 bit. So definitely we have to use 4 digit of hexa. Cap, your answer should be put into 4 digit of hexa. So AX, so you have a 007H, okay. Your BX remain 00DH. Um, lebih kosong kosong 64H ni. Okay, ni pun terlebih kosong. So you have 000DH. So 9, okay, you have 009H. 9 ni dalam decimal. So kita tukar dia kepada hexa, kita letak 9. So jadi kita kata 0009H. So this is how you trace. Okay, nasib baik dalam ni normally for division, okay, so carry flag and overflow flag will not be affected. Okay, because of course, okay, bila you divide, your data will become smaller and smaller, so it's still in the range of the you punya register or memory operand lah. Okay, so the example, this is another question. Okay, how you write your assembly language statement when you have a multiplied positive 5 by negative 30. Okay, so the multiplier, okay, silap kat sini. Okay, so this is 30 times with the negative 30 times with the positive 5. Okay, by the 30. Okay, 5 positive 5. Okay, multiplied by 30. Okay, so okay, so bila kita write the code, okay, pastikan kita keluarkan the statement tu dulu. So apa darab apa, okay, multiply 45 by negative 30. Okay, so by negative 30. So negative 30 times with the 5, multiplied by 5. Okay, multiply 45 by negative 30. So negative 30 times with the 5 lah. Okay, and allocate the result in the 16-bit variable result. So akhirnya your jawapan kena letak dalam result punya variables. Okay, okay. So now kita kena tengok, okay, where is your multiplier and where is the multiplied number. So the multiplied number should be put into the AX, okay, and the multiplier will be put into the others as a source operand lah. So source operand ni yang kamu akan gunakan dalam dekatkan you put into the output. So first, you declare your variables result using a 16-bit. So result space, okay, DW question mark, because we don't know the initial value of your results variable. So and then kita move AX with the negative 30, and then move BX with the positive 5, and now kita nak pakai multiply mole or I mole. So kalau you nampak positive and negative here, so automatically you pakai I mole the BX. So meaning that the values of AX will be multiplied with the multiplier, and then the results here will be actually dia akan letak dalam AX DX. Okay, tapi jawapan akhir biasanya AX lah. Kita ambil AX dulu, okay, and put into the results. Okay, because dia nak allocate the result into the variable of result. Okay, so that's why the AX will be copied into the result using move instruction. So yang ni kita abaikan lah. Okay, apa-apa kena pakai AX. Apa-apa nak darab apa dengan apa-apa nak darab multiply number mesti pakai AX. Betul je lah saya boleh pakai. Kata tak kisahlah dia 8-bit atau 16-bit. Okay, as long as dia multiplied number should be in the AX register. Then bila akhirnya the result also dia akan override put into the AX register juga. So that's why kamu kena hati betul-betul, faham betul-betul bila you pakai mole and imole. So bila you pakai mole for the mole for the unsigned numbers and imole is for the signed numbers. So because signed numbers and unsigned numbers they have different range. Okay, either in the 8-bit mode ataupun in the 16-bit mode. Okay, so be careful lah. Okay, when you writing the code, make sure you understand, plan yourself what you need to do, and then before you writing the code. Okay, alright. So that's all for the division and I division.